Hello everyone, and welcome to Module 2 of our ISCI course. This module is going to look at how humans interact with our environment around us and the species that live in it, and the impacts that we have as humans on that environment, and how we impact the organisms that live there, and what those impacts have on us as humans. So let's go ahead and get started with that. So this lecture is going to be over the very first chapter of our module here. And this is going to be looking at the species approach of sustaining life on our planet. So this is going to look at the concept of endangered species, how humans impact endangered species, and how we can influence the extinction of organisms around us. So, extinction is unfortunately a natural process, natural part of life. Animals evolve on this planet. They are not particularly well suited for their environment that they live in, or they are really well, and then that environment changes and they can't adapt quickly enough. And that's just kind of a part of natural life. Life on the planet is as it is. We come and go, species come and go, they go extinct, and that's just sort of a natural part of life. That natural cause of extinction is called the background extinction rate. How fast organisms go away, how fast they go extinct and things. It's called the background extinction rate. And that background extinction rate tends to be very, very low. And we know this because we can look at the fossil record throughout time before humans started to really have an impact on our environment right around the turn of the Industrial Revolution, right around the into the early 1900s, when we started to really have a massive impact on our globe. We can look at how fast species went extinct throughout the fossil record and things like that. And we know that species don't go extinct very quickly. They have large numbers of them, and it takes a long time for those species to dwindle away kind of to nothingness. But nowadays we're starting to see a shift where species, there's large numbers of them, and then 50, 60 years they're gone. And that's very different than what the historical background extinction rates tend to tell us is normal. So we know something's up there. But also throughout history, there have been some mass extinction events where over 75%, that's what's classified as a mass extinction event, of all living organisms on the planet disappeared at one point in time for some reason or another very, very quickly. You're probably familiar with the one that killed the dinosaurs. That was a combination of comets, diseases, climate change, all kinds of things. The comet was just the tipping point that sent them over into their decline stage. But there have been 5 or 6, we're in the 6th stage, but there have been 5 mass extinctions throughout the history of the globe that have been caused by climate change and catastrophic events like comets, all kinds of stuff, just massive things, volcanic eruptions happening on our planet. And we know this throughout the fossil record by looking at that natural background extinction rate. We can see that 1 or 2 species fall out of the fossil record every couple of years, and that's normal. We see them for a long period of time, then we don't see them anymore in the fossil record. But what happens in these mass extinction events is we'll see those species, lots of those species, and then all of a sudden, all of these species that we're used to seeing just go away. Just randomly go away at one point in time, and then you don't see any of them anymore. So you know something happened there. So you don't see 1 or 2 little species just disappearing everywhere. You see a bunch of species that were very abundant just suddenly disappear in the fossil record. And that's how you know that you're dealing with a mass extinction event. We'll talk about that in just a second. We're kind of dealing with a mass extinction event in the current era in time due to our activities, which is what we'll talk about a little later. But when you're talking about species extinction, there's a couple of types of species extinction, and it's not so straightforward as just they're not there anymore, it's gone. There's local extinction. And local extinction occurs when an organism that was commonly found in one particular place is no longer found there anymore. Although they might be found everywhere else where they're normally found, or they're gone in this one particular place. And you can look at this, things like the peregrine falcon. The peregrine falcon that lives in the United States right now, originally there were 2 different species, the eastern and the western peregrine falcon. The eastern peregrine falcon was is biologically extinct. DDT, overhunting, lots of things caused its local extinction. It's no longer here anymore. But the species overall, the peregrine falcon, still exist. The ones that are here now are reintroduced. Western peregrine falcons, they're introduced here to repopulate the area. So the original falcons that were here are no longer here anymore. And this can also occur when species don't come back. They leave the area, they're gone forever. And this can occur, this occurs from hunting, diseases that hit a particular area, but they're still found somewhere else in their range, but they happen to just be gone in that area where they once historically were found. And that's a local extinction. They're no longer found where they used to be. And then you can have ecological extinction. And an ecological extinction occurs when a species is still there, but there's so few of them that the role that they used to play in the environment doesn't really happen anymore. It's kind of like if you're garbage collection people, you only had one of them now. They're still there, but there's not enough of them to pick up all the garbage for everyone, and the fallout from that would be horrible. And species that like this are things like wolves. Wolves have been target for massive campaigns of reintroduction because they're so important in the environment, but when their species drops, their numbers drop really low in the environment, there's really bad fallout effects that can occur with this because the wolves control the population levels of things like elk and bison. So when the wolf population goes down, there's not enough wolves to prey on the sickly bison and the weaker bison, so the populations overall become really sickly, they're not very healthy, and then eventually what will happen is the entire bison population will crash, and that's not good. So ecological extinction is the loss of an organism to the point where they're not able to do what they usually do anymore. They're still there, but there's not enough of them to really matter. And then you have the biological extinction. And biological extinction is the concept that everyone's familiar with, where all the organisms are gone. There's absolutely nothing that we can do to get that organism back. Now, the first two types, the local and the ecological extinction, we can target as humans to try to save these species. We can reintroduce, as I mentioned with the peregrine falcon, we can reintroduce that particular organism to an area where it used to be, where it's not anymore. We can put it back there, protected the habitat and put that organism back. We can foster the population of wolves, protect their environment so their numbers rebound, so they're able to play their important role in the environment again and control the bison and elk population. So lots of different things that we can do to help mitigate these problems. But the permanent loss of extinction at the current moment is kind of here nor there if we can bring it back. There's lots of ethics involved in that, which might be a really good topic for class discussion. So keep that one in mind, the bringing back the extinct animals. So that might be something good to look at. And then there's another type of extinction that's not on here called functional extinction. And functionally extinct organisms are things like the northern white rhino. There are like 3, I think, northern white rhinos that are alive on the planet. 1 male, 2 females. The male happens to be sterile, so cool. That's useless. A sterile male cannot reproduce, so I'm glad the organism's there, but functionally they are extinct. Or things like the Spix macaw. The Rio movie, the blue macaw. The real life one's called a Spix macaw. There's like 40 of them or something in existence. They're extremely inbred. They have a very high death rate for chicks when they hatch. So the species overall, it's still there, but they're probably going to go permanently extinct in the near future without some sort of extreme intervention kind of thing. So those are the different types of extinction. And we'll talk about what we can do as humans to fix this or to mitigate these, and what causes organisms to go extinct in just a second. So once again, this is our time scale of mass die-offs throughout the globe, throughout the history of time on the planet. You can see here our mass 5 extinction rates. One of them was caused by the comet that killed the dinosaurs. One of them was caused by the end of the Ice Age. And then the rest of them happened to be caused by climate change and various other things like that, Earth shifting around, volcanic eruptions. And you can see here it took a lot of time for life on Earth to evolve enough species where something like a mass extinction event could occur in the first place. So once these things occur, those species are permanently lost. They're not going to come back. But once they're gone, new organisms take their place, and then those organisms last for a while, and then some extinction event occurs, and then new organisms take their place, and so on and so forth throughout the history of time. So those will continue. We are in a new extinction event, the 6th extinction event, which we'll talk about a little bit later. So how do we as humans influence this extinction rate? How do we cause this normal extinction rate to go higher? Well, we as humans have populated the entire globe. We can be found pretty much everywhere. You are going to be very lucky if there's a single place on the planet that you as a human, except for down in the deep oceans obviously, but like on the earth, on the surface anyway, on the land, where you would be the very first person that's ever been there. And there's also a very high chance that there's probably going to be some sort of human remnant leftover garbage or something like that. So we have been everywhere, and we have disturbed and touched pretty much everything on our planet. And where we go, we leave behind permanent impacts, and sometimes not for the better. So we have disturbed up to about 60 to 80% of our entire usable Earth's surface. Of all the land on Earth, humans have put some sort of structure, turned it into a farm, cut down the wood that was once previously there, or anything at all to the land other than what it normally was. If you don't think that's a valid statistic, look at the size of trees. Trees live 300 and 400 years, and they get massive. So if you think about it, trees have been around forever. There should be trees in your front yard everywhere on the planet. Everywhere that we look in the entire United States should have trees that are 400, 500, 6 years old that are huge, but they're not, because the entire country for the most part has been logged. Every single tree that was here during the colonial time has been pretty much cut down. Those old growth forests are very hard to find because we've logged our entire country. Pretty much every tree that was ever here when George Washington was here has been cut down. So that's just a little thing just to think about. If we do that with our country and just with the trees, imagine what we do with everything else that we come in contact with. We've also done a lot to the water as well with our recycling practices of dumping garbage and toxic waste products and electronic waste and things into the ocean for permanent disposal. We just haul them out into the ocean and dump them off the side of a boat, and that's it. So when we dump these toxic chemicals into the ocean, or we cut down trees and we cut down these old growth forests, or plow a savanna for a prairie for a farm, or build a house somewhere, the organisms in the environment that was once there is going to be drastically impacted by our activities. If we dump mercury in the ocean, which is what's found in batteries and things like that, lithium, all kinds of fun stuff, the organisms that are found there will eventually take in a lot of those toxic byproducts. When we cut down the trees, the organisms that live in those trees can't live there anymore. They're not there. The trees aren't there for them to live in. So our activities of just existing as humans are not really pleasant for life on Earth, if you think about it. So the current annual extinction rate on our life on Earth is about 0.1%. So about 0.1% of the organisms that we've identified on our planet will go extinct every single year. That's kind of scary. It's historically speaking very much lower than that, and it's very likely that that statistic is kind of flawed and is also very low compared to what it probably should be. Our activities as humans are going to be compounding as life moves forward for us. If you've ever seen the experiments before where people drop, if you ever watched a chemistry class, it's called titration, and they put drops of a pH solution indicator into another solution of something of acid or something at the bottom. And you drop one little drop, 2 little drops, 3 little drops, and you can drop something like 300 or 400 drops in some of these solutions. But that last drop will instantaneously turn that entire solution pink. It'll be clear, 300 drops. We'll take it 299, it'll be completely clear. That 300th drop will instantaneously turn that entire thing pink. And that's kind of what's going to happen with our environment. We're building up and building up and building up, throwing more and more garbage out, making more and more greenhouse gases, pumping it into the environment, all of this stuff, until eventually our ecosystem won't be able to handle it anymore, and something's going to happen. And what's going to happen is a mass die-off of the life on the planet. It's already started, coral reef collapse, things like that. So a lot of these environments, also things like the rainforests that are vitally important for life on the earth in the sense of making just oxygen for us. There's so many different types of organisms that live there. There's no telling what the plants that live there might do for medicine. A lot of these places have also been damaged to the point where there's nothing we can do to fix it. Rivers like the Ganges River in India have been so damaged by human activities and ecological runoff and toxic waste and things like that, that even if we stopped right now dumping stuff like that into the environment, that it would take hundreds of years and thousands and hundreds of thousands of dollars, if not more, to restore these environments back to the way that they should be, if it's even possible at all. You have to think about places like Chernobyl with toxic waste or nuclear waste that won't be habitable for hundreds of thousands of years. So our activities, let alone how they impact us, the organisms that live in these places have to deal with that as well. And they don't know what's going on. They don't understand that, oh, there's a toxic waste here, you shouldn't drink the water. They just do it because that's what animals do. And they have to live in these environments because that's just how they are. It's just kind of how evolution programmed them to work. And they don't have a choice if they want to live in these horrible environments or not. That's just what they do. And they have to deal with what we do to these environments. And a lot of the times they have a very difficult time dealing with that. And then they pay the price for our activities. So a lot of these places are damaged to the point where we might not be able to save them. And the species that live there, the only thing we can do is do our best to protect them as best we can, or else they will go the way of their environment if we're not careful with that. So, how do we know that our estimates for these extinction rates are right? We don't, but we know that we've started to see a lot of the organisms around us not there anymore. And we know that natural extinction takes a really long time due to our fossil record. We don't see massive amounts of organisms just dying all the time. We see that 5 times throughout history, and they're millions and millions of years apart. We don't see that every 100 years, every 50 years, and things like that. But now we're starting to see that. Organisms that we've identified aren't there anymore. Their numbers are just drastically falling all across the planet, different types of environments and things like that. So we know that something's going on. We also know that we don't know what all is out there. We've only identified about 2 million species on the planet. It's estimated that there are up to 10, if not more, million species that are out there. So if those species that we don't know about go extinct, how is anyone going to know? It's if a tree falls in the woods and no one's around here, it doesn't make a sound argument. And then we don't really know also what the organisms in the environments do for one another and what roles they play in that environment. So if one organism goes extinct and everybody's kind of like, who cares? That might be the one organism that ties everything together. That might be the wolf of that particular ecosystem. So if the wolf goes away, that entire ecosystem might collapse and then the whole thing might fall apart. So we don't necessarily know as scientists what every organism does and how important they are. So I think it's kind of worth the hedging our bets of just protecting everything, because if we don't, we might lose something that has a bigger fallout than we're expecting. So everybody's always trying to get better models for this, figuring out how to measure animals. It's very difficult, very costly. And also, they're very hard to find. A lot of these endangered organisms, they're endangered, which is they're hard to find. So it's not so easy as just going out in your backyard and looking for deer. You have to go hunt these organisms down, or just know where they happen to be, which sometimes can be thousands of miles away from a town up in the jungle or the rainforest somewhere. So it's not as easy as it seems. So why do endangered species matter? Why do we care? And what is an endangered species? But well, these guys matter because they're kind of the smoke before the fire. When you start to see organisms go away from the environment that they're normally perfectly fine in, you know that something's up. They wouldn't go away if they didn't have to, is kind of what I'm getting here at. They have to go away because our activities are causing them to either move or die. So when we see that, we know that there's something up with that environment that's not normal. So we should pay attention to that and try to fix whatever that problem is, because when they leave, or when they're gone, they're not going to come back under their own control, because we're probably just going to make that problem worse and move more into their habitat or dump more toxic waste into the environment that they once lived in. So what is an endangered species and things like that? So an endangered species is an organism where there's so few members of the species in existence on the planet that they run the possibility of a very high possibility of becoming extinct very soon. Now, this can be for a number of different reasons. Endangered species could have genetic problems, things like cheetahs. There's a bunch of cheetahs, but they have a really high death rate as cubs. They have problems with genetic diseases and inbreeding because their genetic diversity is just not very high. They went through something called a bottleneck event. You can look that up later, and that might be a really good thing to discuss in class as well. So keep that one in mind. So cheetahs, it's very difficult for these guys to breed and have successfully surviving offspring in the wild. Things like pandas, there's so few of them that without us helping them along the way, that they run the risk of becoming permanently extinct. And then you have a threatened species, and that's another term that gets thrown around a lot. Or vulnerable species is another term that's tossed around. And there's still enough of these guys that they're able to maintain their populations in the wild at the current moment. But their numbers are not as stable or as high as they used to be. And in most cases, the numbers are declining of these particular things. So things like caribou, reindeer, in the wild, their numbers are declining. Things like polar bears. There are enough of them around that they're able to fulfill their role in the environment, that they're able to breed, they have high genetic diversity and things like that, but their habitat is shrinking, and the numbers that were once historically there are now shrinking. They're going down to a point where if this trend continues, they will hit the endangered species mark, where they might not have enough of them to be able to maintain that population in the wild without our help. So endangered and threatened species are flags, if you like, or flags on the play that indicate something's wrong, that we really need to pay attention to as humans. So, what are the characteristics of our endangered species, and why do they become endangered in the first place, or threatened? Well, there's a lot of reasons why organisms can become threatened or endangered to start with. And one of them is they just have a very low reproductive rate to start with. If you have an organism that reproduces every 5 to 6 years, like a panda, they reproduce every 3 years, a rhinoceros every 2 and 3 years, and they carry their offspring for 2 to 3 years at a time, things like rhinos or elephants, you're not going to be pumping out babies every 2 or 3 days, 2 or 3 weeks, like things like mice. It's going to take 5 or 6 years for an elephant to have a baby. So you can't expect the population of elephants or pandas and whales and things to just grow like crazy, because it takes them 5 years to have a baby. You can't expect those organisms to be bountiful in nature because it takes them so long to reproduce. A sad fact of life is that some organisms are just rare to start with. There's just not a lot of them out there. For multiple reasons. Their habitat is so difficult to find, or they breed so slowly. There's just not a lot of them to begin with. So those organisms are sometimes prone to that problem. But there's also some that just have a really low reproductive rate. Even though there might be a few of them out there in the environment, quite a few of them, it takes so long to reproduce that any single loss to that population is threatening. So people that hunt rhinoceroses and people that fish tuna and marlin and things like that, those fish take 5-6 years to reach maturity to the point where they can be big enough to even possibly breed, if not longer for some of those species. So when you harvest a breeding fish, you're potentially taking 100, 200,000 babies out of that environment every single couple of months or years when that fish reproduces. So even the loss of one panda, one tuna, one rhinoceros can drastically impact those species as a whole, because it takes them so long to reproduce in the first place. You can have organisms that play such a specialized role in the environment that when that role is threatened, or when that environment is threatened, that they have a very difficult time adapting. So things like the Everglades kite that eats a specific type of snail, or they live just in the Florida Everglades. When the Florida Everglades environment changes, they don't have anywhere else to go because their food's not found anywhere else, or the environment that they eat that they hunt in is not found anywhere else. So when their environment changes, they don't adapt quickly enough. Evolution takes thousands of years for an organism to be able to successfully fully adapt to a new environment. And when they change instantly, they don't adapt quite quickly enough in the most part. So they're going to probably not survive, and they'll go extinct. So when we impact environments and cause them to change instantly instead of over hundreds of thousands of years like nature usually does, they don't have enough time to adapt. Sometimes animals are just rare, like I mentioned to start with. The axolotl, you guys have probably seen them before. They look like the little salamanders with the gills. They're commonly found in pet stores. They're really cute. They're only found in like 4 lakes in Mexico. So they're at risk to go extinct anyway. They're nowhere else on the planet. If those 4 lakes are gone, they're gone. And that's exactly what happened. They're gone in the wild. They're everywhere in the pet store across the world, but there's not a single wild axolotl to be found. Humans caught every single one of them for the pet trade or the genetics testing trade, and they have clear skin, which makes them good test subjects. So that's a problem too. If you're only found in 2 or 3 places, if those 2 or 3 places get damaged, it's over. And then you have organisms that are just kind of rare to start with because they're at the top of the food chain. If you have thousands of tigers out there, they're going to eat every single deer in existence in India and Russia that they can get their claws on. So you can't have thousands and thousands of tigers, thousands of grizzly bears, because they'll eat everything. You have to have more prey animals than you have predators, because if you didn't, they'd eat everything, and then everybody would go extinct because the prey wouldn't be there anymore. So their populations are limited as high as they can go because of what's happening around them of the prey, with that prey-predator relationship. They're so high up in the food chain that there can only be so many of them to start with, because if there's more of them, they'll eat all the prey animals, and then the prey goes away, and then everybody dies. And then you have organisms that have fixed migratory patterns, things like sea turtles, whooping cranes, the blue whales. These organisms travel vast distances across the planet, and they go the exact same way every single time. Now, we don't know if this is hardwired in them genetically, or they learn this, or they look at landmarks. It's probably a combination of all of them, and they might use the sky or the stars to navigate all this stuff. Who knows? But they follow the same routes from place to place across the globe every single time. You probably know that sea turtles return to the exact same beach that they were born on to lay their own eggs. Even though they spent the entire rest of their life swimming around in the entire open ocean, they just know how to get home. Well, the problem with this is they follow the same route every single time, but humans do too when we travel across the globe. So if we have ships that travel through the blue whale's migratory pattern, or the sea turtle migratory pattern, or we build a dam or something in the middle of a river where sturgeon migrate up the rivers and down the rivers, those organisms are going to have difficulties getting to the places where they once were able to go, and then they have a difficult time getting to where they need to go. So if we build a dam in the middle of a river, the sturgeon can't get up to their breeding ground anymore, and then they just die. So that's a huge problem. Shipping going through whale migratory patterns. The big ships crash into whales all the time and kill them. Um, we build houses in the beaches where sea turtles live. They come back every single time, and people step on their nests and things like that. So um, we can't fix where the animals go. We have to fix what we do. Because they're not going to change. That's evolution. We can't talk to them and tell them, hey, our boat's coming through, you need to watch out. We either have to deal with the fact that we're going to kill all the whales or figure out something else to do. And then once again, like I mentioned, some organisms are just hard to find to start with. It's just kind of a sad reality of life. They're just rare. Kind of the little, it's just kind of how it is. They're just hard to find. And then some animals, even though they might have large populations or might have historically had large populations, they're worth something to people. And unfortunately, that's what we as humans associate wealth with, and things that we need to take care of and things that we should care about, as if they're worth something to humans. And when I say worth something, I mean as in we can make money off of them, not as in the typical sense of worth. Not, oh, I think it's a cute animal, I like that. Worth something as in monetary wise. Elephants, their tusk, rhinoceroses, their horns for medicine in Southeastern Asian countries, tiger skin, tiger teeth, the pellets of snow leopards, the pellets of tigers, the claws of snow leopards, all those things are used for traditional medicines, bird feathers, all these different types of organisms are poached in illegally harvested birds for the pet trade, by the way. People love pet birds. They'll go harvest them out in the wild, in the rainforest, and they ship them across the globe, and they ship them in plastic bottles. You can find horrifying videos of this on the internet, and they'll just go catch all flocks of birds with just net guns, and just ship all of the birds out of this environment across the planet for people to have as pets. And when they do that, those organisms are no longer in the wild anymore, or they're dead. And then they can't reproduce. So when an organism has an inherent monetary value to it, its chances of survival are pretty slim, because people are always going to value money over the life of an animal. So they will poach and kill every single one of those things until there's no more of them to poach, for the almighty dollar. And that's just kind of a sad reality of life as well. And then you have organisms that have really large territories, and this puts you at risk as well. If you're an organism that needs something like half the county to live in, to hunt and successfully get all the prey that you need every single day, you have to remember that prey organisms, things like deer and elk, they move around too. They don't just stay in one spot. It's not like going to the grocery store and getting food. You have to hope that they walk into your territory. So the bigger the territory that you have, the higher the likelihood of an organism, a prey thing, running in to your territory, and you not running into somebody like another grizzly bear or a panther or something that's going to cause problems for you. So the bigger the territory is kind of the better. But the downside of that is when you need a 500-acre territory, the chances of you coming in contact with some sort of human activity is really high. You're probably going to have to cross a road, or come in contact with people and garbage at some point in time. And when you do that, it puts you at risk of getting hit by a car, or the organism learning that there's food there, and then the bears starting eating out of the garbage cans, and then people getting feeding the bears, and then the bears attacking the people, and then the bear eventually has to be killed. So the larger the territory, the greater the chance of that territory also being broken up by housing developments and logging, all kinds of stuff. So organisms that need those big territories, it's very difficult for them nowadays with so many people to maintain what they need to survive. So their numbers are also dwindling as well. So this is a lot of the things that can cause organisms to go extinct. There are tons of other things that can cause organisms to become endangered, not extinct. So there are tons of different reasons, and this just happens to be a few of them. So if you can think of any more, bring that to class and we'll talk about it. So this is the ice you see in red list. This is a list of organisms that are considered critically endangered, in need of human intervention to maintain their populations. A very interesting little list. So how do we as humans impact this extinction rate? How do we cause organisms to go extinct? What do we do? Well, there's an anagram that you can use for this, and it's HIPPCO. habitat destruction, degradation, fragmentation, invasive, non-invasive species or non-native species, population growth, pollution, climate change, and overexploitation. We'll talk about what these mean, but the biggest one is loss of habitat. As we as humans grow more of us, as our population grows, we need more land. We need more places for people to live, so more houses. We need more farmland to grow the food for these people to eat. We need more places for them to work, all this stuff. So we need more places for their waste to go, not just garbage, but bodily waste and things like that. So we can't just throw it out in the yard. Well, we can, that's what we do sometimes, but that's not healthy. So we have to have ways to deal with all this stuff. So as our population grows, the organisms that are around us and the habitat that they live in is going to be what's paying the price for that. We're going to expand into their house. They are not coming into our habitat. We are going into theirs. And that's kind of what people don't understand a lot about animals, is we're moving into their house. They aren't moving into ours. So habitat destruction is one of the biggest things that's a threat to species extinction overall. And why? So this is what habitat destruction and fragmentation looks like. This is in the rainforest. This happens across the United States as well. I think this one happens to be in Canada. These are all pine fir conifers. And this happens when areas are just completely changed from what they used to be for one reason or another. Now, this place was logged. You can see they went in and cut down every single tree that was there. Now, this is habitat fragmentation. So you can see here what happened is the habitat was, they cut down every single tree except for this little square in the middle. Now, if you're a bird, you can fly from these trees to these trees, or from over here to here, and over here to here, get from place to place. But if you're an organism like a monkey in the rainforest, or an orangutan that lives in Indonesia and Borneo, and you need to get from here to here, you can't. They move by the trees. They have a really hard time walking. They can. But when they walk out in the open, it puts them at risk from predators like tigers. People kidnap them and sell them into the pet trade. People will kill them for meat as well. So anytime that these organisms venture out of their normal habitat into the open, they put themselves at risk. So they don't tend to do that. So this habitat over here and the organisms that live in it are now basically cut off from any of the other organisms that they're of their own species and this environment that they once easily had access to, that they could just walk to. So they can't get there anymore. So this habitat has become fragmented. It's been cut up into small little pieces that the organisms that are stuck in those little fragments are now pretty much contained to. If you have to think about the fact, if you're a rabbit, this is a really long distance for you to travel in the open and hope that you don't get eaten by a hawk or an eagle or something that's flying overhead. That's a really long way. Or a deer or something that hope that the wolves don't see you. So animals aren't going to naturally cross these things unless they just absolutely have to. And they usually won't. So habitat fragmentation is a big deal. And not to mention the fact that all these trees are now gone. So all the nutrients that the trees provided, there were probably countless animal nests that were in there, are all now gone as well. The bugs that lived there, all kinds of stuff, the nutrients and the oxygen that these plants provided are all now gone. So the environment is now permanently changed from what it once was, and it will take hundreds of years to get back to the way that it once was. So the animals that are there, they're obviously not going to survive hundreds of years without their normal environment, so they're going to pay the price for that as well. So as we continue to log and build more houses and cut down and pollute, this is what's going to happen. The animals around us will pay the price for it. So another big deal is introduced and non-native species, invasive species. We move animals around the globe. We move around the globe and we take our animals with us. And we do this either on purpose or by accident. you're really probably familiar with organisms that we've done this with on purpose, things like horses, cats and dogs we bring with us from country to country. Horses aren't native here. They haven't been since around the end of the Ice Age. So the Spanish colonizers brought them over with them, reintroduced them. Cattle the same way. They were brought over here on purpose. But things like zebra mussels arrive on accident. A lot of the times when commercial shipping occurs, either through boats and things like that, or through the air, foods and things like that, airplanes, stowaways come with them. So boats, commercial shipping boats and things like that, they have a bunch of water that they use to balance the ship out when it's empty. So they fill the bottom hull full of water, the boat sinks, it's called ballast, and so it's not top heavy anymore. And then when they're loaded up with all their shipping contents, they pump the water out and it balances the boat out equally, so they're not top heavy. Look that concept up if you want. You don't need to know that. Anyway, so when they fill their hull up with ballast water, they just suck in water from the sea or the ocean or the lake, wherever they're at. And then when they get to wherever they're going, they need to offload, they dump that ballast water. So whatever happens to be in the ocean that they suck up, fish or little mussels or anything like that, is going to travel with them from wherever they were all the way to wherever they're going, and then they're going to dump that into the ocean or the sea or the lake in a brand new environment. So lots and lots of organisms have moved around that way as well. They can show up in fruits and things. Spiders and bugs accidentally get moved around all the time in food products. Or shipping in wooden containers, wooden boxes and things. The little insects will burrow into wood, and then we don't know that they're in there. Somebody moves a wooden pallet from India or China or somewhere to Russia or the United States and introduces a brand new pest from those areas, and then that's what happens. So that's what an introduced or an invasive species is. It's something that's not meant to be here, and we've either brought it here on purpose or on accident. And when different species are introduced to areas where they're not naturally found at, things can go downhill from there. Organisms that have evolved in the United States, they have predators here. Organisms around the United States know what that organism looks like. They know that it's safe to eat or not safe to eat, how to kill it, if they can at all. That organism knows what to eat and things like that. So organisms know what to do with the organisms that are around them. But when a brand new organism is introduced to an ecosystem, the organisms that are around it don't know what to do with it. They don't know if they can eat it. They don't know if they can prey on it. They don't know if it's a predator. So for the most part, they're going to ignore it. So there's very little that's going to cause a threat to these invasive species. And most of the time, they tend to overcompete and outcompete and be a little better at playing ball than the organisms that were naturally there to start with. And that's a big deal. So when organisms come in, they can either be introduced as predators, and when a new predator is introduced to an area, the prey organisms in that area don't know that that's a predator. It's kind of like the concept of you don't know that you need to look out for big gray hawks because there are no gray hawks in your environment that eat you. But now a new hawk is there. None of the organisms have ever seen a big gray hawk, so they ignore it. And then by the time that they realize that it's a predator, they're dead. So they don't ever learn because nobody survives the encounter to be able to pass their genes on, and that species, genetic knowledge that that's a predator, we need to be aware of that. So all of them go away, or their species are drastically threatened because of that new introduced predator. They can compete with native species. They can use the same breeding grounds. They can eat the same food. So if they do that, well, I was eating here first, and now some other random person is eating here, a random thing is eating here, and I have to share my food with them? I don't think so. So when that happens, both are getting 50-50 and not 100% like they were to start with. So both organisms are going to pay the price for this. The native species is going to have its population impacted, as well as the non-native species is not going to be as successful as it could be in this new environment. So the native species is going to be negatively impacted, which is a bad thing. We don't want that to happen. And then they can be parasites. There are quite a few introduced species that will prey upon as parasites to things that are native species. Things like lamprey will eat native fish species. They suck their blood off and things. They don't outright kill them for the most part, but they can cause the spread of disease and things like that. So introduced parasitic species are a big deal. So here's a couple of species that are introduced. Some of them are introduced in the sense of we brought them here, and then we have invasive, and invasives are ones that cause harm to the environment for the most part. The honeybee brought here obviously for honey production. The kudzu plant was brought here. You see this all over the place. In the south was brought here to control erosion. The nutria brought here for fur. The European wild boar, or the feral pig, was brought here for meat production for pigs. I don't know if you know this, but you can literally take a pink Porky the pig off the farm and let it go, and then within a couple of months, they'll pretty much look like this. They revert back to that wild boar stage very, very quickly. So that's what those guys are. They're just domestic pigs that got out into the environment they broke their fences down and then just started to reproduce. The environment here is very much like Europe, where they were originally found. And that's what happened. I should probably mention that. The environment that these invasive species and introduced species are now put into is generally going to be very similar to the environment that they came from. And they find that very pleasant. So when they find a new, very similar environment, they can just go to town. And that's what happens. So the pigs that are from Europe find the American forest very similar to Europe, so they have no problem adapting very quickly. They don't even know they're not in Europe, and they just go to town. The nutria are found in South America. They were brought for fur. They got out or were deliberately introduced in parts of Florida, and now they're all over the place because the Florida Everglades are very similar to the wetlands where they live. And then we have a couple of accidentally introduced species, things like sea lamprey, brought in through, once again, that ballast concept in ships that I mentioned. They're parasites of fish. They cause disease and big lesions on the sides of fish and things, found all over the Great Lakes now. They're originally from the ocean. The Argentinian fire ant, brought here through shipping, trade in plants, international trade in plants and things. The Burmese python, which we'll talk about in a second, from Indonesia and India and places like that. The termite is also not native here, and the zebra mussel, which is a huge deal. Zebra mussels were brought here to that ballast concept in the 70s. They were introduced into the Great Lakes, and now they've pretty much spread all throughout anything that's connected to the Great Lakes via the Mississippi River and all the little tributaries around it. They outcompete native mussels, and they kill native mussels by growing faster. They're better filter feeders than the organisms that natively live there. These guys will grow so fast they will cause boats to sink because they clog up the intakes or the little things that pump out water on the boats, or they'll cause so much weight from mussels themselves to actually sink the boat. There's millions of dollars in business of zebra mussel removal all throughout the Great Lakes. These guys are from Russia. So where they're naturally found. So very interesting concept with these invasive and introduced species. Their impacts on the environment are detrimental. The native species that live here now have to put up with something that they don't know about, that they don't know what it is, they don't know how to handle it, and it's either going to kill them, eat their environment, grow over them, cause them to not be able to grow, or downright kill them in some way, shape, or form. So those are really bad. So invasive species and us just bringing animals in willy-nilly via the pet trade is not a good thing. So our Burmese pythons are all over the Florida Everglades. These guys are from Burma, Malaysia, Indonesia, India, places like that. They grow about 20 to 25 feet long. They weigh a couple 100 pounds. They grow pretty quickly, and they eat anything they can get in their mouth. So it's not just Burmese pythons, it's African pythons that were brought over as well as pets. And these guys, when they get them as little babies, they're cute little baby snakes, and then all of a sudden they get huge. You got this cute little baby snake, and then it's 6 foot long in a couple of years, and it's eating a rabbit every other day. And people don't want to deal with that anymore. And instead of surrendering that organism to the Humane Society or a zoo or something, as they responsibly should have, they just took it outside and dumped them in the Everglades. There have been also countless hurricanes which have knocked over pet stores and things like that. So these animals got into the Florida Everglades. Now, when they got there, they found the Florida Everglades very, very similar to the swamps of Indonesia and Africa, where they're naturally found, where they naturally live. It's pretty much the same environment, the same temperature, the same water. It's pretty much the exact same place, and they love it. There's nothing here that's ever seen a snake that big before, so they don't know that it's a threat. They don't know what it is. So the deer that live down there, the Florida key deer, alligators and things, don't know that these organisms are a threat. The birds, the organisms, fish that live there have no earthly idea that they need to be worried about these organisms. So these snakes just eat everything that they can find. They eat all the mammals, they eat birds, they eat some of the native reptiles and things, some of the different native snakes, they eat alligators, and they eat all these native species, whereas nothing else does either. Nothing else would. So there's no natural predators for great blue herons in the United States, but now there are, except for but with these stupid pythons. So that heron, which naturally has no predators, now has a predator. So its population is going to be drastically impacted by these goofy snakes that were introduced that never were once a threat, and otherwise the heron's population would be perfectly fine. So egrets, all kinds of stuff, are drastically impacted by these stupid snakes. And they eat everything they can get their mouths around. All day long. They reproduce extremely quickly, and now there's tens of thousands of them all over the Florida Everglades. They literally pay people bounties to go out and hunt these things. There's a huge trade in the skins for fashion items and things, gun belts and boots and stuff. So there's big money that can be made in these. But it's sad that we have to incentivize the hunting of this to control the spread, rather than just not telling people to dump their pets in the Everglades. But that's how people work. So prevention is kind of the best way to keep these stupid species from moving around. We need to figure out what species are before we move them. People don't do that a lot. They just get a species, they move it to another place, and they don't know what's going to happen to that animal or what that organism needs before they get it. They get it, and then they go, oh, this is too big, I don't want to feed this, and they just let it go. And then that's what happens. We end up with snakes or snakehead fish, all kinds of stuff. Another good concept for class, different types of introduced species and how they got here. We need to inspect goods before they come into the country. Anything that's wooden, that's not treated, now it's required for most wooden products to be put through a kiln, and heated to a certain point that'll kill most living organisms before they're brought from country to country. That's different from place to place, but most countries have that kind of law. But if they didn't, or they used to not, they do now. But before that, anything that was inside of that wood, little larval grubs or beetles or things, bugs, that happened to have gotten inside of that wood would just move with the wood. So they just would get here, and then they'd burrow out of the wooden pallet that they were brought over from wherever they came from, and then start causing problems. That's a woolly adelgid, is an organism that's brought over that way. We can make it illegal to move things from place to place. That's a big deal. We got lots of Burmese pythons in this country. We don't need to import anymore. Pretty easy on that one. We can require cargo ships to be free of different things. We can inspect them, cause them to dump their ballast out in the ocean, all kinds of different things. And we can just increase research, and just tell people about different types of invasive species and what they can do to help inform and control the spread of these different types of things. And just what you can do to not go dump your goldfish out in the yard or tell your neighbor to do that. Because you can find goldfish in lots and lots and lots of ponds and lakes and streams all throughout the United States, even though they're native to China and Japan, because people just dump their pets out into the ponds and things, and there you go. What else can cause organisms to grow extinct on that list? Human population and growth, solely related to habitat loss. The more of us, the less habitat they get. So when their habitat goes away, they go away as well. Overconsumption, we use a lot of stuff. If we cut down the whole rainforest, they're not going to have any food. So we cut down their food, and that's what happens. Pollution. We can pollute our environment. If we pollute the environment, they can't live there anymore. So the food that they eat won't be able to grow, or it'll be so contaminated with algae and things due to way too much nutrients, eutrophication, that nothing else can live there. It's just full of algae and full of snot. You've seen fish tanks that are just so green that the fish can't live in it anymore. It's just choked with algae. That's what happens when we contaminate environments with nitrogens, phosphorus, things like fertilizer. Climate change, when we make our ocean hotter, when we pump different types of carbon things into the environment, it causes acid rain, which causes the little organisms like coral and stuff that use sodium bicarbonate to make their shells to not be able to harvest that from the ocean because the acid causes it to degrade, and they won't be able to build their shells anymore, and then no more coral reefs. So that's what's happened to the Great Barrier Reef in Australia. It's pretty much collapsed because of that. And then we can just overexploit the animals as a whole. We harvest them, we kill them for different reasons, and when we kill so many of them that they're gone and they're not going to come back anymore. The passenger pigeon is a perfect example of that. Somebody that should look that one up for a class discussion. That's a really good one. The extinction of the passenger pigeon, and how humans influence that one, or the thylacine, another one that how humans directly influenced the extinction of species. Birds are another great signal right now for us as humans that things are not looking particularly pleasant for us in the future. About a third of the 800 or so identified species of birds in the United States, I love birds, are threatened. And this is mainly due to habitat loss. Not every bird species migrates. And when species of birds don't migrate, if their habitat is threatened where they live, they got nowhere else to go. And then sometimes when birds do migrate, they migrate from place to place, but one place can be contaminated and the other place is fine. And then when that happens, they end up with some serious problems. So birds are at a particular risk for humans coming in and cutting down their forests that they need for nesting and their nesting lands, particularly ground-dwelling birds and things like that. The way that we have giant skyscrapers, this is a really good one for somebody to bring to class for discussion. Birds. I love this one. We can talk on this one for a while. So somebody think about this one. And then there are so many introduced dangers to birds. Cats, for one. Different species have introduced snakes and things in different islands across the globe. But in the United States, cats are one of the biggest deal, as well as starlings. You've probably seen European starlings in your front yard. They're a little kind of brown, speckly bird that's kind of iridescent. They make all kinds of funny sounds in big flocks. Those guys aren't native here. They were introduced in the 1800s into New York City Central Park. Started out with just 100 birds, and now this is what we have. So a wonderful case study of invasive species. They were introduced on purpose by the Royal Shakespeare Society of London, who wanted to bring every single species that Shakespeare wrote about in his books to the United States. It took them 3 tries to get the starlings introduced to the United States. They had 100 of them shipped over at a time from England. They introduced them into the Central Park of New York the first time. They all died. They couldn't survive the winter. The second time, 5 or 6 of them made it. And then the third time, here we go, 1887 or something around in there. But those birds, there's no predators here for them for the most part. Most birds here don't really know what they are. They don't hunt birds in big flocks like that. So those birds have no problem living here, and they outcompete for nest space with native birds. If you've ever seen the big gourds hanging around, those are for purple martins. Purple martins only nest in gourds and human-made houses. There are no wild nesting purple martins in the United States or anywhere else in the entire globe. They only nest in human-made structures. And in fact, those gourds date back hundreds of thousands of years. The Native Americans used to hang them around to keep the birds, to control pests on their farms, which was interesting. But anyway, those stupid starlings nest in those things, and then the purple martins don't have anywhere else to nest. So every single starling that takes over a purple martin house, there's one less purple martin that's going to be having a successful nest. So big deal with those. And then not to mention how many cats there are that live outside that kill birds. And then tons of other things: oil spills, pesticides, lead poisoning. If you hunt ducks or know somebody that hunt ducks, you're only supposed to use steel shot when you're out hunting ducks, because the lead shot from upland bird games shells will contaminate the water. So the lead will get out there, it contaminates the water, and the lead leaches into the water. If you shoot into the water, shooting at ducks and things, the lead builds up in the water. It causes reproductive problems with ducks and other waterfowl and things like that, as well as fish and stuff. And it can even cause problems with land hunting. The California condor, they eat carrion. So people that hunt coyotes and things will shoot them and often leave them out to die, or leave them out to rot in the field. So vultures and California condors and things will fly by and eat those dead animals and get the lead bullets inside of them, and then it'll poison them slowly over time. So that's even a big deal. They get caught in fishing nets all the time. People abandon fishing nets. They float on the surface of the ocean, so the birds come down to get fishing, to get the fish, and then they get caught in a net or some fishing line or something like that, and the bird drowns. Climate change, huge threat to birds. They don't handle climate change very well at all. And then we harvest them and hunt them all the time. The Carolina parakeet is a perfect example of this. It was the only native parrot to the United States. Every single one of them was killed for their feathers. Kind of unfortunate, because they're very beautiful little birds. They were all killed. The entire species went extinct in the 1920s due to the fashion explosion of women wearing full mounted birds on their hats. Theodore Roosevelt's wife wore one, and then the fad kind of exploded. So birds are they're one of the most sensitive organisms in the environment to changes. So when they start to have problems, we should probably pay attention to that, because they're kind of the first indicators that something's up. So what can we do, and what have we done to help control this? So we have something called CITES right now, which was passed in 1975, which is the Convention on the International Trade in Endangered Species. 175 countries at the moment are signatories to CITES. And this is we won't harvest or allow anyone to bring or sell or export ivory or rhino horn from this country. Or if we do have an organism that leaves this country that's endangered or comes in, it's going to be logged and tracked and really, really watched and monitored how these organisms are transferred around the globe. Because we want to know where they're going, where they're at, if one of them is harvested and when, and things like that. So we want to make sure that we know what's happening with these organisms, so we can make sure that they don't go extinct, and that we're all working together to help. Because people like pets in different countries, they like medicine in different countries. So just because an organism is found in one place doesn't mean that it's not being used or desired in another. Pet trade and medicine trade is a huge threat to endangered species. Also another good topic for class. So we have the Convention on Biological Diversity, which focuses on protecting the ecosystems that animals live in, and it's ratified by 193 countries except for us. Kind of interesting. We have in our country the Endangered Species Act, which was passed in 1973. It's been amended a couple of times. And this lays out what we're going to do to protect different types of species in the United States that are considered endangered, which ones are endangered, how we're going to protect them, how we deal with people hunting them, and things like that, when they should come off the endangered species list, all that kind of stuff. We have the Marine Fisheries Service list, which looks at the ocean and the species that live in it. Fish are a huge resource for humanity. We harvest them for both food and sport. And commercially harvested fish, their populations are drastically volatile, depending on our activities. If we overharvest them, they can crash. If we underharvest them, they'll grow a lot, which is a good thing. So we want to make sure that we're not overharvesting these particular types of fish, especially ones that are endangered to start with. And then we have the U.S. Fish and Wildlife Service, as well as the game wardens, the local fish and wildlife, state fish and wildlife services. that deal with the protection of endangered species and threatened species on a federal and local area. Game wardens and federal game wardens do a lot more than just look for people that are poaching and hunting and things like that. Another really good discussion topic, the necessities of game wardens and what they do for people as a society, and what would happen if we didn't control hunting and things like that, and maybe the volatility or the necessary evils of hunting and things like that. So another good topic for class. There's a couple of other things that people do. And then mostly what we can do is we can incentivize people that own land, especially people that own lots of land, to protect that land. Don't let people just go ride four-wheelers and dump garbage, and protect the property that you own, and make sure that you're not just cutting down the logs and things like that. So the organisms that live there can continue to have a place to live. They're threatened enough as it is. So if you can help out just a little bit, give them a little bit of something. So kind of nice on that one. So how do we help this? How do we improve the Endangered Species Act in the United States? It's basically obvious. Way more money. Help these organisms develop plans to recover. Get species listed that were once threatened, get them on the list for endangered. Get research rolling, get breeding programs established, get their environments protected, all kinds of stuff that we can do to help these species. So we've established wildlife refuges. The very first one was established in 1903. Theodore Roosevelt, ironically enough, was a huge hunter. There's a nice relationship between conservation and hunting, but I just find that kind of odd. Loved animals and things like that, but was also one of the very first people to establish, the first person, I should say, to establish a national wildlife refuge in Florida, which is kind of cool. And to date, there are around 560 or so different types of refuges in the national wildlife system. And a lot of them are wetlands, which are vitally important for things like ducks and herons and fish that come in to breed in these wetlands, and turtles and things, and beavers and stuff. But we don't have a lot for plants. We need to protect a lot more area for things like trees and different types of plants that are found out there that are endangered as well. So how do we protect these plants? There's lots and different types of animals, but for plants, you can make a seed bank, which is kind of cool. There are lots of these across the globe, which is exactly what it sounds like. They just take seeds from different types of plants that are endangered, and they freeze them, and they stick them in a cooler underneath lock and key for hundreds of years, just in case these plants ever go extinct. If they do go extinct, we can pull some seeds out and say, oh, here it is, it's not extinct, and grow them back. And that's essentially the plan on that. You can make a garden, a botanical garden, or an arboretum where we grow these endangered plants, or we put them there on purpose so people can come and look at them. And we have a place where we can make sure that these organisms exist, even though they might not be found so much in the wild, that they're found a lot in captivity, which is a good thing. And then we can just raise them, farm them, and things like that. We can farm endangered species. There's a large industry in farming rhinos, which is kind of ironic in South Africa. They farm them for both commercial sale of their horns, which is legal only in that country. That's an interesting discussion topic if you want to go there. But they also sell them to zoos. They sell them for private ownership. It's just kind of odd. But rhinos are vastly endangered and threatened. So, I mean, they are making more rhinos. So it's kind of a good thing, I guess. It's just kind of weird. So that does exist as well. Zoos and aquariums are a way to help preserve endangered species. But it's not a permanent solution. There are only so many zoos, and those zoos can only hold so many rhinos or so many lions or so many polar bears until they're going to run out of space too, and then they're not going to be able to hold any more. So we're either going to have to stop breeding or put down the organisms that are born, which is counterintuitive to what the point of a zoo is. So this is not a long-term solution of zoos. But the long-term goals for zoos is to reintroduce these organisms that they're breeding back into the wild. So if we don't protect the habitat that these organisms live in, there's no point for the zoos to do their work. So two things have to go hand in hand. We have to protect the environment that these organisms live in, so we can reintroduce them back into that environment when the zoo has the breeding programs for them. We can preserve endangered species with egg pulling, which is harvesting embryos from females and freezing them for use later if that species tends to go extinct. They do this with rhinos, endangered big cats, and things like that. We can breed them in captivity, encourage them to breed more of them, and things like that. But once again, money's not an infinite thing for zoos either. They don't have enough money. It takes a lot of money to house a rhino. I assume that's probably not a cheap thing to do. So they have limited space and limited funds. So zoos can't be responsible for everything when it comes to preventing or protecting endangered species. So we gotta do our part as well. We need to stop this and slow it down at least. If not stop it, might be hard to stop, but we can at least slow it down. Slow down our consumption and exploitation of the globe and the organisms that live on it, and just kind of reduce our ecological impact as a whole overall. There are tons of different things that we can do to do that. Also, might be a really good topic for discussion in class. Okay, so why do we care? Why do we care about this extinction rate? Why do we care that it's going up? The organisms that live around us are a big deal. Once again, I mentioned that we as humans tend to associate value with things monetarily, and if an animal can't give us some sort of usable product or some sort of valuable thing monetarily wise, it's not useful for us. We don't care anything about it. We for the most part, could care less if that organism exists or not. It's really hard for people to wrap their mind around that organisms exist and they have every single right to exist as much as we do, and that we should just protect them because they exist, and that's kind of a hard thing to understand. But we also don't know what those animals do, like I mentioned, in the environment. So if we don't protect them all, we might accidentally lose something of importance. So who knows? But then you've got the really obvious ones, things that are useful for pollination, like bees. Without bees, we wouldn't have any pollination for our foods. No fruits and things, no veggies. So that would be a big deal. Natural pests. They eat things like they eat things that we don't like. So you could have things that harvest pests for us. That's a good thing. They produce valuable products for us. That's a good one. Ecotourism. Tons of people travel to Africa to go on safari to see the elephants and the rhinos. So the money that's generated from those animals existing would be drastically reduced and or lost if the numbers of those animals were also reduced or gone. So there's an incentive to keep those animals around. And just once again, I think they're cool, so that's kind of a reason, in my opinion, to keep animals around. And then it takes a really long time for animals to evolve in the first place, so we really don't want to have to wait around for that organism to hopefully evolve again. And you're not going to be able to fix it as quickly as you could stop it. Once something's broken, it's going to be really hard to put back together, but you can prevent something from being broken. And that's kind of how that works. So honeybees, big deal. Let's chat about this one in class, the honeybees, what the big deal with that one is, and what these different types of plants have to deal with that. So are we obligated as humans to deal with this problem? I would say yes. Do we protect everything, or do we protect the ones that are valuable to humans, the ones that are valuable to us, or to you, or to who, or to what country? Do we protect them because we think they're cute, or do we protect them because we think they're fun, or we like them? What and why and which species do we protect? Because you can't protect everything. There's not enough money and there's not enough time to protect everything. And unfortunately, we have to exist as well as they do. And the world's not going to shut down simply because a whale needs to migrate here. So that's kind of a catch-22 as well. Some species are quote-unquote more biologically valuable than others. But we really do need to appreciate all species as they are, because they all do play a role to some extent in the environment. So these are the 3 big ideas that we're going to chat about in class. So give those a look over and be prepared to chat about those when we come to lecture. So that's all I've got for this over endangered species and what they are, what we as humans can do to protect them. So if you have any questions on that one, feel free to let me know. Other than that, have a great rest of your day.